Welcome back to the deep dive. We often look at these seemingly niche industrial sectors,
Yeah,
but they can actually underpin these huge global changes.
absolutely.
Today, we're diving into one of those, the automotive part die casting market. It's a segment that's, well, quietly having some explosive growth.
It really is. It's one of those foundational technologies. It's kind of everywhere in vehicles, but you don't really see it.
Right.
So our mission today really is to pull back the curtain a bit. We want to show you the critical role die casting plays, in making modern cars.
And look at growth.
Exactly. It's rapid global expansion, the forces driving it, and, where the biggest shifts are happening around the world.
And when you say explosive growth, that's not really an exaggeration, is it? Let's maybe start with some big picture numbers. We've got data from Cognitive Market Research.
Okay.
Back in 2021, the global market here was valued at $36.47 billion.
A pretty hefty number already.
Yeah. And fast forward to now, 2025, it's already hit $46.1 billion.
Wow.
That's a huge jump in just 4 years.
It is. And if you look further out, say to 2033, the projection is an estimated $73.67 billion.
73 billion.
Yeah, which works out to a compound annual growth rate, a CAGR, of about 6.03%.
That's pretty robust.
It is. And what's fascinating is this isn't just sort of normal expansion. It's really being fueled by some non-negotiable demands.
Like what?
Well, rising global vehicle production, for one. Then you've got these increasingly strict emission regulations everywhere.
Right, the environmental push.
Exactly. And maybe the biggest driver,
Yeah.
the constant push for lighter vehicles, lighter structures to boost fuel economy and performance.
Okay, that push for lighter vehicles, lightweighting, that seems absolutely central here. We hear the term a lot, but maybe unpack the fundamental need. What does it really enable beyond just, saving a little gas?
Oh, it's way beyond just marginal fuel savings. Lighter structures mean, well, better performance, for starters, improved handling, too.
Okay.
And crucially, significant cuts in emissions. Doesn't matter if it's an internal combustion engine or extending the range of an EV.
Makes sense. Less weight, less energy needed.
Precisely. The less mass a vehicle has, the less energy it needs to get going, to stop, or just to move.
Right.
And the real, let's say the magic of die casting, especially with materials like aluminum and magnesium.
The lighter metals.
Yes, exactly. Is that it can produce these incredibly complex parts. Yeah. Very close to their final shape, near net shape, they call it.
Ah.
And it does it quickly with high precision.
Yeah.
So that means fewer manufacturing steps afterwards, less material waste, and you end up with lighter parts that are still incredibly strong.
So it's perfect for these sort of integrated designs.
Absolutely perfect.
Yeah.
Where you need both performance and efficiency.
So die casting isn't just about making the same old parts lighter. It's enabling sort of new ways to design cars altogether.
That's a great way to put it.
So where are we actually seeing these advanced, lightweight die-cast parts being used more and more?
They're becoming indispensable
Mm.
right across the vehicle. Think about the powertrain first. Engine blocks, transmission housings increasingly made using die casting, replacing heavier stuff.
Right.
But it definitely doesn't stop there. They're also vital in structural components. The frame, the body structure.
Which is key for safety, obviously.
Hugely important for integrity and crash safety.
Yeah.
And here's where it gets really interesting for the future.
Go on.
We're seeing these parts used in complex EV battery enclosures.
Ah, okay. Protecting the battery pack.
Exactly. And that's a massive indicator of how foundational this tech is for the whole electric vehicle revolution. Because in an EV, every single gram you save directly impacts the battery range.
That's a critical point. So it's clear this technology is shaping the future, really, of all vehicles, whether they're gas, electric, or hybrid.
For sure.
So given how important die casting is becoming for transforming vehicle design, the next question has to be, where is this playing out most dramatically, globally speaking? Let's maybe take a tour region by region, starting with North America.
Okay, North America. It's still a dominant force, and that's largely driven by the United States.
Right.
The region's market was about $14.52 billion back in 2021. It's projected to nearly double, hitting $28.35 billion by 2033. That's a solid 5.63% CAGR.
Still very strong growth.
Very strong. And what's significant isn't just the size, it's the ongoing investment in, sophisticated manufacturing, especially with the shift towards making EVs.
So the U.S. component.
The U.S. alone is expected to go from about $11.14 billion up to $21.35 billion.
Mm-hmm.
But you should also keep an eye on Canada.
Oh, yeah.
They got really robust momentum. A 6.9% CAGR projected, going from $1.55 billion up to $3.31 billion.
Okay.
And Mexico's growing fast, too, projected to reach $3.7 billion by 2033.
So it sounds like the whole regional supply chain is strengthening, not just assembly anymore.
Exactly. It's moving much more into advanced component manufacturing across the board.
Okay, let's hop across the Atlantic. Europe. Steady, strong growth seems to be the story there.
Yeah, steady and strong is a good description. The market's expected to grow from $10.58 billion in 2021 to $20.62 billion by 2033. That's a CAG of 5.62%, very close to North America's rate.
And which countries are really anchoring that growth, and where's the most sort of dynamic change happening?
Well, Germany and France are still central, absolutely. Both are projected to get close to $3 billion each by 2033. Italy is also a major hub for die casting, growing to $1.51 billion.
Okay, traditional powerhouses.
Right. But what's maybe most insightful is the rest of Europe segment.
Meaning?
Countries outside those main ones.
Yeah.
That segment is actually showing the region's highest growth, a 7.02% CAGR, projected to climb to $5.76 billion.
Interesting. So it suggests it's spreading out beyond the traditional centers?
Precisely. New centers emerging, or existing ones diversifying their capabilities right across the continent.
Fascinating. Okay, now let's turn to the Asia-Pacific region, APAC. That market's surging, right? From about $6.86 billion in 2021 up to $14.88 billion by 2033.
Yeah, a really solid CAGR too, 6.91%.
We know China's obviously a huge manufacturing player, but what else is happening in APAC? What are the big stories?
Well, China is definitely the largest contributor, no surprise there. Expected to reach $4.15 billion. That's driven by its huge domestic car market and its role as, a global manufacturing hub.
Right.
But India is a real standout performer in the region.
Oh, really? How so?
It's showing the fastest growth in APAC. An impressive 7.67% CAGR. It's scaling up from about $1 billion to $2.32 billion.
Wow. What's driving that in India?
It's not just about local production. It's significant foreign investment coming in, a fast-growing middle class wanting new cars, and also strategic government pushes for more industrial self-sufficiency.
Makes sense.
And of course, Japan and South Korea remain really crucial players as well.
Okay.
And actually, similar to Europe, that rest of APAC segment, think of those dynamic, fast-growing economies.
Southeast Asia, maybe?
Places like that, yeah.
Yeah.
That segment is forecast to surge from $2.77 billion up to $1.93 billion. That's a region-leading CAG of 8.72%.
That really underlines that widespread industrialization, doesn't it? New auto ecosystems popping up all over Asia.
It really does.
So we've covered the big established regions and the fast-growing ones in Asia. What about South America? Is it showing similar momentum in die casting?
South America is definitely showing solid promise. It seems to be driven by more automotive exports from the region and just a general expansion of manufacturing capabilities there.
Okay.
The market's growing from $2.52 billion in 2021, projected to $5.53 billion by 2033. Brazil's leading the charge, expected to hit $1.65 billion.
And others?
Argentina and the rest of South America are also growing pretty quickly. It reflects, rising local demand, but also better integration into the global supply chains.
And the Middle East, are they making a significant play here, especially with all their economic diversification efforts?
The Middle East is certainly an emerging player, projected to reach $2.28 billion by 2033. The growth rate is a bit more moderate, 4.51% CAGR.
Okay.
But you've got strategic hubs developing Saudi Arabia, the UAE, Egypt. They're becoming more important.
What's driving it there?
Mostly increasing vehicle assembly operations locally. And also, interestingly, a significant and growing interest in electric vehicle manufacturing within the region.
Ah, so they see the EV transition as an opportunity.
It definitely signals a deliberate move towards building more diverse, high-tech industrial bases, moving beyond just oil and gas.
Right. Now, let's talk about the region that's really making headlines for growth. Africa, an incredible story there. The market's expected to surge from just $0.69 billion in 2021.
Tiny starting point.
Tiny. To $2 billion by 2033. That's a massive CAGR of 9.92%. The fastest regional growth we've discussed by far.
It is. It's truly a remarkable story. It points to foundational economic transformation happening.
What's behind that explosive expansion?
You're seeing places like Nigeria, South Africa, and also the rest of Africa category seeing a big rise in localized auto production.
Okay.
And like in India, it's not just basic assembly. It's driven by significant foreign investment, a growing middle class wanting cars, and governments pushing for industrial development.
And that rest of Africa part.
Yeah, what's really striking there is that segment alone is projected to hit nearly $1 billion, or
Yeah.
$0.99 billion, and it boasts the highest regional CGR of all, 10.29%.
Incredible.
It really points to broad-based economic and industrial development finally taking hold across large parts of the continent. It's going to be a critical market to watch.
No kidding. So, okay, we've got this global market that's just experiencing profound growth everywhere almost, driven by these fundamental needs later, more efficient cars, and the huge shift to EVs.
Yeah.
That brings us to the future. What's next for the technology itself? What kinds of innovations should we be looking out for? Things that might redefine die casting again.
Well, the source material points to a pretty clear path for innovation.
Yeah.
We're definitely going to see big advances in precision casting.
Mm-hmm.
For listeners maybe not deep in manufacturing, that means making parts with incredibly tight tolerances, really intricate shapes.
Okay.
This lets manufacturers combine functions. Maybe what used to be 3 parts becomes one single complex die-cast part.
Which saves more weight and simplifies assembly.
Exactly. Crucial for things like complex EV powertrains. Then there's continuous alloy development.
New materials.
Yeah, creating materials that aren't just lighter, but maybe stronger, or more heat resistant, or even better at conducting electricity or heat, depending on what the part needs to do.
Tailored materials.
Precisely. And of course, automation. That's going to play an even bigger role, boosting speed, making sure every part is consistent, and bringing down costs.
Makes sense.
And these innovations, they're absolutely crucial. Manufacturers need them to meet what consumers expect in terms of performance, but also to meet those ever-tightening rules on emissions and safety.
So, wrapping this up a bit, what does this all mean for us? We've done this deep dive into a market that maybe sounds a bit obscure,
Yeah, maybe not front-page news usually.
but it's fundamentally important. The automotive part die casting market isn't just growing steadily, it's on, well, an absolute rocket ship, set to nearly double its value in just over a decade.
It really is.
And this growth is directly tied to that huge shift. Lightweighting vehicles, not just for fuel efficiency, not just for performance, but critically as a foundational building block for the whole future of electric vehicles.
And the global picture shows this really fascinating mosaic of growth, doesn't it? You've got the established giants like North America, Europe,
Holding strong.
holding strong, yeah.
Yeah.
But then these surging new players like India and the incredibly rapid industrialization we're seeing across Africa.
Yeah.
It just underscores how truly global and interconnected the auto supply chain is now. Innovation and manufacturing know-how are spreading really fast worldwide.
Absolutely. You know, this whole deep dive makes me wonder if these advances in die casting are so key to reshaping the automotive industry with these high-strength, lightweight parts, what other heavy industries might be poised for a similar lightweight revolution?
That's a great question.
Could we see traditional materials in places like, I don't know, construction, heavy machinery, maybe even aerospace? Could they be fundamentally challenged, maybe transformed by similar innovations in materials and manufacturing?
It certainly makes you think that need for strength without the weight penalty,
Mm-hmm.
it's not unique to cars.
Right. It raises that question. What other big, heavy industries are ready for this kind of lightweight shift? Definitely something for you, the listener, to mull over until our next deep dive. All right, ready to really dig into something foundational, something that's quietly reshaping the cars you drive and, well, the ones you'll be driving soon. Today, we're taking a deep dive into the automotive part die casting market. Our mission, let's cut through the noise. We want to give you the crucial insights into how die casting isn't just, some manufacturing process. It's actually a key enabler. It's shaping the innovations, the emission cuts, the performance boosts in the auto industry. Think of this as your shortcut to really getting it.
Yeah, and what's really striking right off the bat is just the scale and the path this market is on. Back in 2021, we were looking at a global value of about $36.47 billion. It's already climbed, we think, to around $46.1 billion this year. Okay. And the projections, they show it hitting a pretty impressive $73.67 billion by 2033. That's expanding at a compound annual growth rate of just over 6%.
Wow, okay, over 6% CAGR.
Exactly. And if you connect this to the bigger picture, the core drivers for this huge growth, they aren't just isolated things. They're actually coming together. We're talking lightweight materials, the massive expansion of electric vehicles, and this is critical, next-gen casting technologies.
Those numbers definitely paint a picture of, yeah, rapid expansion. So diving deeper into that growth, what are the key things really pushing this market forward? Is this like a complete rethinking of how cars are built, or more just optimizing what we already do?
Well, it's a bit of both, I'd say, but leaning pretty heavily towards rethinking things. Take, for instance, the huge demand for lightweight parts. That plus increased vehicle production worldwide. Manufacturers are turning more and more to aluminum and magnesium die-cast parts for everything from engine blocks, transmission cases, to, complex structural brackets.
Okay, so it's not just about saving a little weight here and there.
No, not at all. It's absolutely critical for meeting those tougher fuel efficiency targets and the emission standards that keep getting stricter. Globally, the lighter the car, the less energy it uses. Simple as that. It makes die casting just integral to modern car design and, frankly, to meeting regulations.
It feels like you can't even discuss the auto industry now without bringing up EVs. How do they specifically play into this demand for die casting?
Oh, they're a massive accelerant.
Yeah.
A huge factor. Electric vehicles, hybrids too, they have very specific needs. They need parts that are thermally stable. That's crucial, right, for managing the heat from big battery packs, powerful electric motors.
Heat management is key for EVs.
Exactly. They also need incredible precision. Think about the intricate parts in the powertrain. Tolerances are super tight, and of course they still need to be lightweight. Maximize that range, that efficiency. Die casting, it's just perfectly suited for making things like battery enclosures, motor housings, those complex cooling structures EVs need.
So as more EVs hit the road,
Yep. As global EV adoption keeps climbing, the need for these specialized high-performance castings just keeps going up. And it's the kind of thing only advanced die casting can really deliver consistently at scale.
okay, so beyond just meeting the demand, it sounds like the innovation in the casting process itself is a huge part of the story here. What's actually changing in the foundries, on a tech level? What's letting them push these boundaries?
Yeah, what's happening there is fascinating. It's really a revolution within the casting technologies themselves. Innovations like high-pressure die casting HPDC. That basically forces molten metal into a mold at incredibly high speeds, high pressures. You get denser, stronger parts, way fewer imperfections.
Okay.
And alongside that, you have things like vacuum casting, semi-solid metal processes. They're truly transforming what's possible in production. These advances, they let manufacturers produce really complex shapes, complex geometries at high volumes. And with tighter tolerances, significantly fewer defects.
And that means lower costs, better parts.
Exactly. At the end of the day, it translates directly into lower manufacturing costs, yes, but also improved reliability for the components and better performance for the whole vehicle. It lifts the entire industry.
So the growth story is definitely compelling, but, it's never entirely smooth sailing, is it?
Yeah.
What are some of the biggest, let's say, speed bumps or significant restraints the automotive die casting industry is dealing with right now?
Yeah, definitely some big hurdles there. One major one is the volatile prices of raw materials. Fluctuations in the cost of aluminum, zinc, magnesium.
Yeah.
They hit profitability directly. Hard.
Right. Materials costs are always tricky.
And you combine that with the ongoing supply chain disruptions, shipping delays, and things we've all gotten, unfortunately, kind of used to. It creates real challenges in keeping production stable and, cost-effective for these essential parts.
And I imagine setting up shop or even upgrading in the space, it sounds like a massive undertaking, huge upfront capital needed. So that cost must be a major barrier too then.
It absolutely is. That's another significant restraint the high capital investment required. Establishing or upgrading a modern die casting operation. It demands substantial financial commitment. We're talking incredibly expensive tooling, molds, complex machinery, advanced automation systems. The whole 9 yards.
Which makes it tough for smaller companies.
Very tough.
Yeah.
It's particularly restrictive for small and mid-sized suppliers, the ones maybe looking to get into the market or scale up what they have. It just makes it harder for new players to compete with the established giants who have that capital.
And with the whole global push for, greener vehicles, more sustainable manufacturing, I guess environmental regulations are playing a bigger and bigger role too.
Without a doubt, we're seeing growing regulatory pressure, definitely.
Yeah.
Environmental rules about emissions, metal waste, they're getting tougher, especially in places like Europe and North America.
And die casting uses a lot of energy, right?
It does. The process itself is energy intensive. So companies now have to invest significantly in cleaner production tech, in advanced recycling systems, just to stay compliant and, crucially, to stay competitive. It's not really
Hmm.
an option anymore. It's basically a necessity for market acceptance for continued operation.
So, okay, despite these hurdles, innovation clearly isn't stopping. That shift you mentioned earlier to massive single-piece castings, that sounds truly monumental. It makes me wonder, with these huge innovations happening, what are the emerging trends really shaping the future of this industry? Maybe things we wouldn't have even guessed a few years back.
Well, one of the most, I think, fascinating shifts happening right now is towards large structural die castings. Car makers, especially pioneers like Tesla, are using these gigapress systems. These things are literally the size of a small house, huge casting machines.
Gigapress, right, I've heard about those.
And they can produce massive single-piece components, like an entire car's rear frame
Hmm.
or the whole underbody, in one shot. Think about it like stamping out a whole section of the car instead of welding together, maybe hundreds of smaller parts.
Wow.
This trend, it's fundamentally transforming vehicle assembly. You significantly reduce the number of parts. You minimize welding. You dramatically simplify the whole production complexity. It leads to faster, cheaper assembly.
That's incredible. So we're moving from cars built like complex Lego sets to ones almost printed in these giant sections. That completely changes the factory floor, doesn't it? What about the digital revolution? Is Industry 4.0 making its way into these foundries?
Absolutely. Yeah, we're seeing a really robust integration of Industry 4.0 concepts. Smart foundries are becoming the norm. They're getting equipped with AI-driven analytics, things that can predict issues before they happen, real-time defect detection right on the production line, sophisticated robotic handling for moving parts precisely, predictive maintenance for the machinery itself.
So making everything smarter, more efficient.
Exactly. These technologies aren't just, nice to haves. They're dramatically improving product quality, improving yield. And they're also significantly cutting downtime, boosting energy efficiency across the board. It's really about making the whole casting process smarter, more resilient.
And speaking of efficiency and resilience, sustainability has to be a major trend now, right? Especially with the auto industry's bigger net zero goals. How is die casting playing a role there?
It's front and center.
Yeah.
With automakers all over the world committing to net zero, to decarbonization goals, there's a strong and growing movement towards using recycled aluminum and developing more sustainable metal alloys.
So not just virgin materials.
Right. And this isn't just like a marketing thing. It's a critical effort. It aligns with circular economy ideas. And it helps automakers meet those crucial ESG benchmarks, environmental, social, governance, without compromising performance or safety. Plus, using recycled materials significantly reduces the energy needed for production. It's a win-win. So to kind of sum it up, what's fascinating here, I think, is that the automotive part die casting market, it's clearly entering this era of high precision, high efficiency. As electrification expands everywhere, as environmental rules get stricter, die casting is going to keep being this crucial enabler for cost-effective, lightweight, and genuinely sustainable vehicle production. It's fundamentally shaping how cars are actually made.
And that leaves us with a really thought-provoking question, I think, for you to ponder. Considering the immense capital investment needed for these advanced die casting technologies, and you couple that with the industry's push towards these massive single-piece structural parts and deep sustainability efforts, how might these shifts fundamentally reshape the traditional landscape of automotive manufacturing? Beyond just the foundries themselves, how will it impact the entire supply chain? The roles of different players within it, from material suppliers right through to final assembly lines. Definitely something to think about long after our deep dive ends today.